Ever wonder how we went from computers barely understanding basic math to AI writing poetry and composing music?
Honestly, it's kind of mind-blowing when you think about it.
Right? It really is.
Yeah, like we're talking about a complete paradigm shift in how we think about machines.
Well, buckle up, because today's deep dive is all about Yoshua Bengio,
Ah, Bengio.
the man who fundamentally shifted how machines learn.
And it all starts with a question, really a fundamental question that's driven Bengio from the very beginning.
Okay, I'm intrigued. Lay it on us.
How can we make machines truly learn?
Truly learn.
Yeah, like humans do.
Okay, so we're not just talking about making computers faster or more efficient here.
No, no.
This is about changing the very core of how they process information.
Exactly. Think of it this way.
Yeah.
Imagine a child, right? Learning about a cat for the first time.
All right, got the visual.
They don't just memorize the word cat, do they?
No, they make all sorts of connections.
Right. They see its pointy ears, its fluffy tail, the way it moves.
They build like a whole understanding of catness based on all these interconnected features.
Exactly. They're not just memorizing a label, they're building a rich, multifaceted understanding.
I see where you're going with this. Before Bengio, computers were stuck in that memorization phase.
Totally. Like they could recognize a cat in a picture.
Right, if you programmed it with the exact specifications.
Exactly. But they didn't truly understand what made it a cat.
They didn't get the catness of it.
Precisely. And that's where Bengio's work on neural networks comes in.
Okay, this is getting really interesting.
He was fascinated by this idea, right, of mimicking the human brain.
With its web of interconnected neurons?
Exactly. Except back then, neural networks, they were considered, well, kind of a fringe idea.
Really? Why is that? I mean, it seems so obvious now.
Well, it was all about symbolic AI back then.
Yeah, I remember reading about that. That was all about programming computers with very specific rules for everything.
Yes, like a super detailed recipe for every single task.
If this, then that kind of logic.
Exactly. Symbolic AI was the reigning king. But you see, Bengio, he saw its limitations.
He saw that it was too rigid, too inflexible.
Precisely. He knew that to truly mimic human learning, machines needed to move beyond these rigid rules.
They needed something more adaptable, more organic.
Exactly, more like how our brains work.
So even as a young computer scientist at McGill University in Montreal,
Early days.
Bengio was already swimming against the tide.
He had this vision, this unwavering belief in neural networks.
What drew him to neural networks when everyone else was so focused on symbolic AI?
Well, even as a teenager, Bengio wasn't satisfied with computers just crunching numbers.
Really? So it wasn't just about the technical challenge for him?
No, not at all. He was fascinated by cognitive science, by the inner workings of the human mind.
He was trying to bridge the gap between these two worlds.
Exactly. This dual interest in computers and e-cognition, that's what led him to neural networks.
So he was always interested in that learning aspect, even from a young age.
Oh, absolutely.
It's like he had this intuition that true AI wasn't just about programming.
It was about something more.
It was about teaching machines to learn for themselves.
And that intuition, that unwavering belief in the power of neural networks, well, that would eventually revolutionize the field.
It's amazing to think about him having that vision so early on.
But it wasn't an easy path, let me tell you.
It sounds like he was up against some pretty established ideas.
Oh, absolutely. This was a whole different way of thinking about AI.
What were the biggest challenges in those early days of neural network research?
One major hurdle was the limitations of training deep neural networks.
Okay, so we're talking about actually teaching these networks, getting them to learn.
Exactly. Imagine you're trying to teach a computer to recognize a cat in a picture.
All right, I'm with you.
You show it thousands of images, and each time it gets it wrong, you need to adjust its internal connections.
To improve its accuracy.
Right. But with these deep networks, with so many layers of connections, it was incredibly difficult to do.
Okay, that makes sense. So where does Bengio fit into all of this?
Well, this adjusting the connections process, this is where Bengio made one of his most significant contributions.
This is where he really made his mark.
He developed and refined techniques that made it possible to train these deep neural networks, allowing them to learn from massive amounts of data and make connections that were previously impossible.
So we're talking about a time when most researchers had given up on neural networks.
Oh, totally. They thought it was a dead end.
They were like, nope, this isn't going anywhere.
Exactly. But Bengio, he saw the potential, even when it wasn't obvious to others.
He was like, I'm telling you, this is the key.
And it's important to remember that Bengio wasn't alone in this.
Oh, right. He had his crew,
Exactly. He was part of this small but dedicated group of
the
researchers.
neural network gang.
Yeah, you could call them that, including Jeffrey Hinton and Jan LeCun.
Oh, yeah, those guys.
Bah.
The godfathers of AI.
Exactly. These guys kept the flame of neural networks alive during those lean years.
The rebels of the AI world. I love that. So what were these techniques that Bengio and his colleagues were developing?
Well, they were tackling some really fundamental problems.
How did they overcome the limitations of training deep neural networks?
One key breakthrough was refining a technique called backpropagation.
Backpropagation. Okay, gotta admit, that sounds a little intimidating.
It sounds like something out of Star Trek.
Right.
But it's actually a really elegant idea.
Okay, so demystify it for us.
Imagine you're building this giant, intricate machine, right?
Yeah.
With thousands of knobs and dials.
All right, I'm picturing this massive, complex contraption. So what does backpropagation do?
Backpropagation is like having a feedback system for your giant machine. Each time you show it an image.
And it gets it wrong.
Exactly. Say, it mistakes a dog for a cat.
Which, to be fair, can be an easy mistake.
Right. But backpropagation helps you pinpoint which knobs and dials need adjusting.
And by how much?
Exactly. And that's how the machine learns to improve its accuracy.
Ah, so it's not just about making the machine work, it's about making it learn from its mistakes. That's really cool.
Right. It's like teaching the machine to self-correct, to get better over time.
But you said earlier that training these deep networks was a problem. So what was Bengio's contribution to backpropagation?
Well, imagine that this giant machine isn't working quite right. It's sputtering, producing inaccurate results.
Okay, I can see the problem.
Bengio's work, in essence, provided the much-needed oil and fine-tuning this complex machine needed.
He got it running smoothly.
He figured out how to make backpropagation more efficient and effective for deeper, more complex networks.
And that's huge, because those deeper networks, they're the key to more sophisticated AI, right?
Exactly. This breakthrough is a major reason we have things like facial recognition on our phones.
Wow, so Bengio's work is literally everywhere.
It's true. And AI generating realistic images, that too.
It's amazing how these fundamental breakthroughs have led to such tangible applications.
It's the ripple effect of innovation. And speaking of unlocking potential, Bengio's contributions weren't limited to image recognition.
Oh, right. He wasn't just a one-trick pony. What else did he work on?
His work also revolutionized how AI processes language, something even more fundamental to our human experience.
Yeah, this is where I get really excited. Language is so nuanced, so complex.
It's true. Language is incredibly challenging for AI.
How do you even begin to teach that to a machine?
It's one of the biggest challenges in AI research.
What was the state of things before Bengio's work?
Before Bengio, AI treated words like simple labels.
Simple labels, so not very nuanced.
Not at all. Think of it like this. Imagine you have a box of crayons, and each crayon represents a word.
Okay, I like this analogy.
And here's the catch. All the crayons are the same shade of gray.
What? That's not very helpful.
Exactly. There's no way to distinguish cat from dog or love from hate based on their meaning.
They're just different labels, no depth.
Exactly. They're just placeholders without any real meaning.
So there's no understanding of the relationships between words.
None whatsoever.
The way we inherently grasp that cat and dog are both animals.
Right. Or that love and hate are opposite emotions.
Hmm.
Exactly. And that's where Bengio's insight was revolutionary.
This is where he blows everyone's minds again.
He pioneered techniques to make AI understand words through their relationships, their contexts.
So instead of just seeing words as isolated units, it starts to understand the web of meaning that connects them.
Exactly. Imagine taking those gray crayons and suddenly infusing them with vibrant, distinct colors.
Okay, now we're talking.
Suddenly, cat and dog are closer in color.
Reflecting their shared animal nature.
Exactly. While love and hate are on opposite ends of the spectrum.
So it's not just about recognizing individual words. It's about understanding the entire network of meaning that connects them. It's about teaching AI to think about language more like humans do.
You got it.
Yeah.
And this conceptual breakthrough paved the way for some of the most impressive advancements in natural language processing we see today.
Okay, so we've gone from gray crayons to a vibrant spectrum of meaning. I'm really loving this analogy, by the way.
It's a good one, right? It really helps to visualize what's going on.
It really does.
All right.
How did Bengio's work actually make that happen? What are some of the specific innovations that came out of this new understanding of language?
One of the most significant outcomes is something called word-to-vec.
Word2vec. Okay.
And it kind of picks up where we left off with the crayons. Imagine taking all those colorful crayons, those words, imbued now with their relationships to other words.
Right, they've got all their meaning packed in.
Exactly. And plotting them on this vast map.
A map of language. Okay, now you have to tell me more about this.
Exactly. So on this map, words that are similar in meaning, like cat and dog, they would cluster closer together,
Makes sense.
while words with opposite meanings, like love and hate, would be miles apart.
Oh, I love that. So it's literally mapping out the relationships between words visually.
Exactly. This map, created using Bengio's ideas, allows AI to understand words not just as individual units.
Which is how they were stuck before.
Exactly. But as points in a multidimensional semantic space.
So it's like AI can now visualize the connections between words, see the constellations of meaning that we humans often take for granted.
Precisely. They start to get the nuances of language.
This is starting to sound a lot like how our brains might process language, isn't it?
Yeah, it's getting closer, right? And this is where it gets really interesting. Word2vec wasn't the end goal, it was a stepping stone.
Okay, so it was like a stepping stone to something even bigger.
Exactly. This new understanding of language, of words as vectors in a semantic space, it paved the way for even more powerful language models.
The kind of models that are blowing everyone's minds today.
Exactly. Like, think about Google Translate.
Right. It's gotten so good, I use it all the time.
I know. And then there are those eerily human-like chatbots.
Yeah. Those are both amazing and kind of creepy at the same time.
Right. It's like they're becoming more and more human-like.
It's true. So Bengio laid the groundwork, and then others built on his ideas to create these incredibly sophisticated language models.
Exactly. He's like the architect who drew up the blueprints.
And then other researchers took those blueprints and ran with them.
A perfect analogy. And one of the most significant developments that came out of this line of research is something called transformers.
Transformers. Okay, I've heard that name thrown around a lot.
They're kind of a big deal. Remember how we were talking about AI understanding the relationships between words in a sentence?
Yeah, like how cat and dog are both animals, while tractor is something completely different.
Right. Well, transformers take this concept of relationships to a whole new level.
Okay, so they're like the next generation of language understanding.
Exactly. Imagine you're reading a book, right? And instead of just focusing on each word individually.
Yeah, which would be a pretty limited way to read.
Totally. Imagine you can hold the entire chapter, the entire story in your mind simultaneously.
Wow, that's some next level comprehension.
Making connections between characters, plot points, themes all at once.
So transformers can see the big picture, the whole context.
Exactly. While also understanding the nuances of individual words and phrases.
That's incredible. They're like the ultimate multitaskers of the language world.
Precisely. And that's what makes them so powerful. They can process vast amounts of text, identify patterns and connections.
That would be impossible for humans to grasp, even if we tried.
Exactly. And then they can generate incredibly sophisticated and nuanced language.
This is all pretty mind-blowing. It really is amazing to see how far this field has come.
And it's all built on these fundamental ideas.
But it also makes me wonder, where do we go from here? What's next for AI and for Yoshua Bengio, the man who's helped shape so much of this field?
Well, Bengio is not one to rest on his laurels, that's for sure.
He's always pushing the boundaries.
Exactly. He's still deeply engaged in research, pushing the limits of what AI can do.
What are some of the big questions he's tackling these days?
Well, one thing that really sets Bengio apart is that he's not just interested in making AI smarter.
There's more to it than that.
He's also acutely aware of the potential impact of this technology on society.
He's thinking about the big picture, the ethical implications.
Exactly. Bengio believes that AI has the potential to solve some of the world's most pressing problems.
Like what kind of problems?
Oh, you name it. From healthcare to climate change, AI has the potential to make a real difference.
It's true. The possibilities seem endless.
But, and this is a big but.
Okay, I'm sensing a but coming.
He also recognizes that it could be misused, that it could exacerbate existing inequalities, or even pose existential threats if we're not careful.
So it's not all sunshine and roses.
It's a powerful tool, and like any tool, it can be used for good or for bad.
It's a double-edged sword.
Exactly. So while Bengio is excited about the potential of AI, he's also very cautious.
He's not just blindly optimistic, he's a realist.
Exactly, and that's why he's such a crucial voice in this field.
He's not just a brilliant researcher, he's also a conscience.
He's asking the tough questions, the ones we need to be grappling with.
It's a lot to think about. So where does he see the future of AI heading?
One area Bengio is particularly passionate about is the development of AI for social good.
AI for social good. I like the sound of
Me
that.
too. He believes that AI can be a powerful tool for addressing issues like poverty, inequality, and access to education and healthcare.
It could really level the playing field.
Exactly. But he stresses that this can only happen if we prioritize ethical considerations.
Ethical considerations. That's key, isn't it?
Absolutely, in every stage of AI development and deployment.
It's not just about building cool technology. It's about making sure that technology benefits everyone.
And it doesn't leave anyone behind.
Exactly. It's about using this powerful tool responsibly.
Couldn't have said it better myself. Bengio's story is a powerful reminder that the most profound technological advancements, they often come from a deep sense of purpose.
Not just from wanting to build the next cool gadget.
Exactly. A desire to not just understand the world, but to make it a better place.
His journey from those early days of neural networks to the forefront of AI research is truly inspiring.
He's a true pioneer, a visionary.
And it sounds like his journey is far from over.
Oh, absolutely. He's just getting started.
I, for one, can't wait to see what he does next. So, as we wrap up this deep dive into the world of Yoshua Bengio, I think the biggest takeaway is this. The future of AI isn't predetermined.
It's a blank slate.
It's being shaped right now by the choices we make, the questions we ask, and the values we prioritize.
And by the pioneers like Yoshua Bengio who are leading the way.
Absolutely. And on that note, we'll leave you with this thought. What role will you play in shaping the future of AI? Until next time, keep exploring, keep questioning, and keep diving deep.